With problem 24, we have f of x equals 4 over the square root of x. So this is kind of a rational function, but it's also a radical function. So sometimes I call it a rational, radical, radical, rational, whatever. We're looking for the derivative, that is the function that will give us the slope of the tangent to that curve at any point. So we start off with f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x and all over delta x. The next step is to take the original function, and wherever we see x, we're going to replace that with x plus delta x. So we have the limit as delta x approaches 0 of 4 over square root of x plus delta x minus f of x, which is just 4 over the square root of x, then all divided by delta x. Before we can proceed with doing the rationalizing on this, we can't rationalize when we have that denominator. Usually we rationalize a radical in a denominator, but not a radical in a fractional expression in the denominator. So the first thing that we have to do is get rid of that complex fraction, or simplify the complex fraction. And the way we do this is just like with regular fractions. We're going to multiply top and bottom by the least common denominator of that numerator. And that would be square root of x times square root of x plus delta x. And we need to do top and bottom that way. Alright, at this point we can multiply out. We need to, for the numerator, to distribute the square root of x times square root of x plus delta x to the first term. When we do, square root of x plus delta x will cancel, and we'll be left with 4 times the square root of x. And then we subtract from that 4 times the square root of x plus delta x. Then our denominator becomes a little bit more complicated, and that is delta x times square root of x times square root of x plus delta x. And so now we're ready to rationalize the denominator there, to rationalize, the radical expression, and we're going to multiply top and bottom by the conjugate of that expression there. Before I start that, I have a factor of 4 in the numerator that I'm going to factor out and then move out. You might recall we have properties of limits, and one of them says the limit as x approaches a of a constant c times a function is equal to the constant times the limit of the function. And colloquially speaking, that means we can just move a constant through the limit and it becomes a multiple. So we can do the same thing with the 4 over here. So we'll move that out and get 4 times the limit as delta x approaches 0. Next, I'm going to multiply top and bottom by the conjugate of the radical expression. And just so there's no confusion, I'll move the 4 out in the step above also. So now we have square root of x minus square root of x plus delta x. We're going to multiply it by its conjugate, and we get first term squared minus second term squared. And that is x minus the quantity x plus delta x. And you can see that that x minus x is going to be 0, and negative delta x will be left. The denominator is going to become more complicated. We have delta x square root of x times square root of x plus delta x, then times the quantity square root of x plus square root of x plus delta x. Now when we simplify the numerator, we'll have 4 times the limit as delta x approaches 0 of negative delta x over the same denominator. And now our delta x's can cancel, leaving a negative 1 in the numerator. And we'll rewrite up top. And at this point we can set all of the delta x's to 0 because it won't cause the denominator to become 0 any longer. So we have 4 times the limit as delta x approaches 0 of negative 1 square root of x times now square root of x, since that delta x is 0, times square root of x plus square root of x. So we have 4 times the limit as delta x approaches 0 of negative 1, and the square root of x times square root of x just becomes x. And we assume that had to be positive in the first place, otherwise square root of x would be undefined. And square root of x plus square root of x is 2 square root of x. And actually we don't need the limit as delta x approaches 0 anymore. So we have negative 4 over 2x square root of x, or negative 2 over x square root of x.